Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 7 of lesson number 2, is matter around us pure? Okay, so in this part we will be studying the further separation techniques which have been left. So probably in part 8, like, we will be discussing the exercise and the summary, and today, like, I'll see to it that, like, we complete most of the part which has been left. We are just left with a small part now, right? And I hope, like, whatever we have studied in the previous 6 parts, you are very much clear with it. Starting from, like, part 1, which was the introduction, we have, like, done so many things so far, right? So I just want each one of you to please revise whatever we have studied till now about solution, suspension, colloidal solutions, and there are so many things, so many properties that we have discussed, right? So I just want you all to please go through the notes that you have made, and then I'll show you all the slides one by one, so that you get a proper idea of how exactly it works. Okay, and you have a proper revision as well. I hope everyone is, like, revising whatever we have studied so far. So now, like, we started this lesson is matter around us by studying on classification of matter, right? So this slide is also very important here, where they have explained us regarding what exactly are pure substances, because according to us, pure substance is something like, you can say, which is considered to be pure and there are no impurities present in it, right? We consider it like that way, but that is not the way. If any substance that you have, or any edible food you have which you can eat, is mentioned as it is pure ghee, pure milk, pure this, like, any substance be it, okay, it means they are stating it that this contains a single type of particle. What does it mean? That it contains a single type of particle. Getting my point, everyone? So this is what you should be knowing, because scientifically pure ghee means it contains only a single kind of particle, and, like, there are not much particles in it. So I just want each one of you to please go through it once. After this, we discussed on what exactly mixtures are. So I just want each one of you to please go through it once. After this, we discussed on types of mixture. So I just want each one of you to please go through this slide as well, because here we have an activity discussion. So please go through it, everyone. After this, we had this activity 2.2 to discuss. So I just want you all to please go through this as well, because this is also very important, right? Then we discussed on what exactly solution is. So I just want each one of you to please go through it once. So here we have like most important, you can say, parts given, where we have different types of solutions, their properties which have been given. So I just want each one of you to please go through it once. Okay, then we had the examples of solutions which have been given, so I just want each one of you to please go through it as well, because you should be knowing the different examples of solutions, what exactly it is. Okay, after this we had the properties of solutions which have been given, so I want each one of you to please go through it once. Now they can ask you a separate question on to write the properties of solution, write the properties of colloidal solution, write the properties of suspension. So like they can ask you this. So make sure that you're aware of it. Okay. And even here we have some of the examples, that is homogeneous mixture examples. So I want you all to please go through it as well. After this properties of solutions, we discussed on concentration of a solution. So I want you all to please go through the slide as well, because here we have the definition of dilute solution, even we have the definition of concentrated solution and what exactly concentration of solution is, right? So see, concentration of a solution is amount of solute which is present in given quantity of solution. Okay, and the solution, if it has small amount of solute in it, we call it as dilute solution. If it has large amount of solute in it, we call it as concentrated solution. Okay, so you should be knowing about dilute and concentrated solution in detail, what exactly they are. Okay. After this we had this activity over here, so I want you all to please go through it once. After this we discussed on like the different ways how can we calculate the three methods, how can we calculate the concentration of a solution, right? Now what exactly concentration of solution is? It is amount of solute present in given amount of a solution. So here we have three different ways of expressing the concentration of solution. One is mass by mass percentage of solution, second is mass by volume percentage of solution, and lastly we have is volume by volume percentage of solution. Okay, so I just want each one of you to please go through it once. Now you should be knowing all the three things over here. Okay, after this, like this is the example that we have discussed regarding like how to calculate the mass by mass part. So I just want you all to please go through it once. Then we discussed on like what is suspension and what are the properties of suspensions, right? So I want you all to please go through it as well once. After this we discussed on the Tyndall effect in detail. So I want each one of you to please go through it once. After this, we discussed on the properties of colloid. So I hope like while you are reading it, you are able to like tell me all the points about colloid. It should be like that way now, because like as this is, we are on to part 7 now, right? So you should be able to know it more properly now. Okay. After this, like here we have few common examples of colloids which have been given. So I want each one of you to please go through it once. After this, we discussed on separating the components of mixture. So which are the different methods that we can use? So we have evaporation, centrifugation, separating funnel, sublimation, chromatography, then distillation processes and all, right? So we have completed studying about evaporation. We completed our study on centrifugation, separating funnel, sublimation, and chromatography. We are just left with distillation part, or I guess we have even completed with distillation. We are just left with few parts on it, right? So we will be doing it as well today. We'll be completing that today. But before that, I want you all to please go through the slide once. I'll be showing you all the separating methods one by one. Okay, and you have to make sure you're going through it and you know it, like what exactly happens in evaporation, what exactly happens in separating funnel, what happens in chromatography, why do we perform chromatography, right? This all things are very important for you to know. After this, we discussed on like how can we obtain the colored component, that is the dye, from blue or black ink, and we can do that through the process of evaporation. Okay, so you should be knowing this thing. We do that through the process of evaporation, and once you go through the activity, you will get cleared like what exactly happens in the process of evaporation. Okay. After this evaporation process, we discussed on like how can we separate the cream from milk, right? So we have discussed that as well. So I just want you all to please go through it, and we can do that through the process of centrifugation. Okay, so you should be clear with this process called as centrifugation technique, what exactly it is. After this, we discussed on like how can we separate a mixture of two miscible liquids, right? So I want you all to please go through it once. And even like in every process, if you see there is a figure representing the process, so you have to make sure you know that representation, how exactly it has been done. Okay. I hope you all are going through this process, and along with it you need to go through the application as well. So this is the distillation technique that we were discussing on, right? So I just want each one of you to please go through it once. I hope everyone is going through it. So here we have like activity 2.8 where we studied about the separation of two miscible liquids by distillation, right? So here we studied about what is simple distillation, what is fractional distillation and everything. And I want each one of you to please go through the slide properly. I hope everyone is going through it, and while you are revising it, while you are going through it, you have to make sure you're even going through the figure. Like as I'm telling you, for every part, there will be a figure for it, right? So make sure you go through it. After this fractional distillation, now we need to discuss like how can we obtain different gases from air. So now we, like you have already studied in your previous classes, like in the previous standards, that air is a mixture of gases where 70% of the air is nitrogen, then we have carbon dioxide, oxygen, 21% of oxygen, right? The composition of air you have already studied, right? Now whatever components with which the air is made up of, we can separate them. We can separate all the different components by fractional distillation process. Okay, so here we have the flow diagram which is going to show us the step of the process. So we have the air, Whenever we are going to compress and cool the air by increasing the pressure and decreasing the temperature, what are we doing? We need to compress and cool the air, and for doing this compression and cooling, we need to increase the pressure and we need to decrease the temperature over there. Okay, and when we do this, what will happen? The air will get converted to liquid air, and now we have to allow this liquid air to warm up slowly in fractional distillation column. Now fractional distillation column is this column that we have studied in the last class, right? Now what is the difference between simple distillation and fractional distillation? It's just that on the on the top of the distillation flask we add one more fractionating column, right? And that fractionating column has been added to it, and this distillation method is called as fractional distillation. So whatever gas that we get after compressing and cooling the air, that becomes liquid air. Now we have to allow this liquid air to warm up slowly in fractional distillation column. What will you do? We have to allow it to warm up slowly, and that too we have to do it in fractional distillation column. And now once we do it, what will happen? The gases will get separated at different height, and here we have the table of oxygen, argon and nitrogen which has been given. So we have the boiling point in degree Celsius and percentage air by volume which has been given. So when it comes to boiling point, the boiling point of oxygen is minus 183. For argon, the boiling point is minus 186, and for nitrogen, it is 1 minus 196, right? And when we calculate the percentage air by volume, it becomes 20.9 for oxygen, 0.9 for argon, and 78.1 for nitrogen. So this is the flow diagram that you should be knowing for the process of obtaining gases from air. Okay, because whatever components with which the air is made up of, we can even separate that. I know many of you might have not even thought of it, that the components of air can also get separated using this fractional distillation, right? Yes, it can be. So I want you all to write this in your book. I hope everyone is writing it. After this, see, if we want oxygen gas from air, we have to separate out all the other gases present in the air, because we know air is a mixture of gases, but we only need oxygen. So for getting that oxygen gas, what we have to do, we have to separate all the other gases from it, right? So air is compressed by increasing the pressure. Like once we increase the pressure, what will happen, air will get compressed and is then cooled by decreasing the temperature to get liquid air. What are we going to do? We are going to compress the air. How? By increasing the pressure, and then we are going to cool it by decreasing the temperature so that we get liquid air. Okay, so this liquid air is allowed to warm up slowly in a fractional distillation column. What will happen to this liquid air? Slowly and steadily it is going to warm up in that fractional distillation column, and the gas will get separated at different height depending upon the boiling point. Now we know that the boiling point of oxygen is minus 183, for argon it is minus 186, for nitrogen it is minus 196, right? So depending upon the different boiling points, we are going to like do it, like separate oxygen from the air. Now as you can see, here we have the filter. The air is going to come inside of the filter, then air is going to be under pressure over here. Through the hot air, it is going to pass through it, and two things will happen over here. The water will move out, and from one side, can you see, the freezing cold water is coming inside and the water is going outside there. And that is how the hot air is getting converted to cold compressed air, because of the freezing cold water coming inside it. And then we have the separator which has been connected, through which nitrogen and argon is like getting outside, and we are just getting liquid oxygen separated. This is what you should be knowing about. Okay, so I just want you all to draw this roughly and write about like how oxygen gas can be separated in short. After this, see, we have the next thing to discuss, like how can we obtain pure copper sulfate from an impure sample. Now suppose you have an impure sample of copper sulfate and you have to purify that so that you get pure copper sulfate from it. Okay, now let's see how exactly it will work. Now if you remember, we have already studied this, right? This is the filtration technique that we have studied. So what we have to do, take some like 5 grams approx impure sample of copper sulfate in a china dish. Okay, what you did, you took some impure sample of copper sulfate in china dish, then you have to dissolve it in minimum amount of water. What will you do? You will dissolve that in minimum amount of water, and then you have to filter the impurities out. What will you do? You will filter out the impurities. Okay, and after filtering it out, evaporate the water from the copper sulfate solution so that you get a saturated solution. What will you do? You have to evaporate water from copper sulfate solution so that you get a saturated solution, and after that cover the solution with a filter paper, and you have to leave it undisturbed at room temperature to cool slowly for a day. And once you do that, you will see that you will obtain the crystals of copper sulfate in the china dish. And those crystals of copper sulfate in the china dish, when you get this crystal, okay, in the china dish, the process that you are using over here, that process is called as crystallization. Now why do we call it as crystallization process? Because you are obtaining the crystals of copper sulfate in the china dish. Okay, so some solids they decompose, or some like sugar they may get charred on heating to dryness as well. And that is why we say that some impurities they may remain dissolved in the solution even after filtration, right? Because of the particle size which is very small. So on evaporation, they are going to contaminate the solid. What will happen on evaporation? They're going to contaminate the solid further. Okay. After this, see, the crystallization method is used to purify solid. For example, if we have the salt we get from seawater, that salt can have many impurities present in it. What it can have? It can have many impurities which will be present in it. So to remove those impurities, we are going to use the process of crystallization over there. Okay. So how can we define crystallization? It is a process that separates a pure solid in the form of its crystal. So if you have to obtain pure solid, you will obtain it in the form of crystal, and we call that process as crystallization. And always remember that crystallization technique is better than simple evaporation technique. So here the crystallization technique has been explained over here. If you can see in the first figure, we have the impure solid and the solvent mixed together. You have to like heat that properly. After heating it, you have to filter it using a filter paper, and once you keep it aside for certain time, what will happen? You will see that you will get the crystals of like crystals of solid in it, right? So this is how crystallization works. Okay, I hope you have understood about crystallization. You can just write, like draw the figure and write the definition of crystallization. After this, we have the application of crystallization to discuss. So see, we can use this crystallization technique for purification of salt that we get from seawater, because we cannot use the seawater, the salt that is obtained from seawater directly, right? So we need to purify the salt that we get from seawater. For that, crystallization can be used. Then for separating the crystals of alum, that is fit curry. Now if you have impure samples and if you have to like purify that. So for obtaining the crystals of alum from this impure samples, we use this crystallization technique. Then by choosing one of the above method, according to the nature of the component of mixture, we get a pure substance. Okay. So when we obtain or when we choose any of the method, and depending upon the nature that the compound components are going to have, we get a pure substance. And when with this advancement in technology, many more methods of separation techniques have been devised. Like in cities, the drinking water has been supplied from waterworks. Okay, that is how it works. That we have a flow diagram of a typical waterwork which has been shown over here. So can you see the reservoir? Reservoirs have been connected to the sedimentation tank where the solids will settle down. Then through the sedimentation tank, it is going to go to the loading tank where what will happen? It is going to sediment the suspended impurities. Okay, then through the loading tank it will go to filtration tank where we'll have like where we will have different layers like water, fine sand, gravel and coarse gravel. This is how like different layers will get formed. And through this filtration tank it will go for chlorination, so that whatever bacteria are present in the water, because after separating all the layers, that is gravel, coarse gravel, filter sand, the whatever water we get is been chlorinated to remove all kinds of bacteria from it. And then after this chlorination technique, it is being like supplied to our house. So I want you all to make this in your book because this is very important. Okay, and even write the application in your book. Okay. I hope everyone is doing it. Okay. So after this, now we are just left with physical and chemical changes to discuss in detail. Along with this physical and chemical changes, we will be discussing on elements, what are the types of pure substances in detail. So here we will be discussing about elements and compounds, because pure substances are further classified as elements and compounds. So we will discuss about elements, we will discuss about the properties, the physical properties of metals, and once you know the properties of metal, the opposite properties are of non-metal. So we will be discussing on the properties of metal. After that, we will discuss about compounds, like what exactly compounds are, and we will be discussing it through this activity which has been given, that is activity 2.10. Okay, after this, we will be discussing the differentiation between mixtures and compound in detail. Then we will discuss on how matter is further classified as pure substances and mixtures. Pure substances are further classified as elements and compounds, and mixtures are further classified as homogeneous and heterogeneous. Okay, after this we will have summary discussion in detail, like what exactly we have studied in the lesson. Is matter around us pure? So most probably in the next part I'm going to complete with this lesson, but after this summary we again have, I guess, 11 questions to discuss at the end of the lesson. So I'm going to show you the exercise questions one by one, and I want each one of you to please go through all the questions, because in the next class probably you will have to answer this. So I don't want any reason you didn't got it, or you didn't understood it. You should be able to answer me this, because I am showing you the exercise questions in every class, and that is for a reason, right? I hope every one of you are going through the exercise questions. I hope everyone is going through the questions which have been shown on the screen. So this is how we will be ending up with the lesson, is matter around us pure? And I hope whatever we discussed today in this part, that is part 7 of the lesson, is matter around us pure, you're very much clear with it. So I will be like continuing the rest of the part which has been left in the next class. Thank you everyone.